Hi! On my 1000th episode I used the PIMORONI's Galaxy Unicorn display to say thank you and celebrate that achievement. So this time I'm actually going to go into that device in a little bit more detail and do a bit of a review of what its hardware capability is and the software library for C++ that comes with it and how you can use that. So we're going to look at 5 separate examples, including the one from the last celebration video, of how actually that device works and some of the nice cool stuff we can do with it. I hope you enjoy the video. Please remember to like and subscribe. I'll see you at the other end of the video. So let's open the box on the Galactic Unicorn, which I've got here and just turned up. So there's not a great deal actually in the box. Some nice packing, nicely packed. We've got the main board there, nicely wrapped up, and when we get that out we can just see that that's got the nice Pico W on the back of it, and it's got all of those wonderful LEDs on the front. That's it's quite a good shaped board, quite a large board with plenty of opportunities in it. And you can also see that there's a nice little speaker on the back there, because this thing makes some sounds as well if you want it to. Also in the box you've got a couple of nice bolts which make a stand for it to stand it at 2 different angles, and a USB cable. The Galactic Unicorn ships with a demo already on it. Not this one, I must admit, I've already blown mine away. But there's a demo on there so you can already see it and plug it in and see the wonderful screen immediately you get it. I've put here one of their demos on for fire effect, which is quite effective. For video purposes I've put a little diffuser in front of the LEDs. Otherwise the camera, they're just a little bit too bright as point sources going into the camera, and it just doesn't really look right. So that's what that diffuser is. Annoyingly, the Galactic Unicorn is a little bit wider than an A4 sheet, and the only sheets of this diffusing stuff I've got are A4. So there's 2 of them, one on top of the other. It's not perfect, I know. Wouldn't be what I'd do for a project. For a quick demo to show you what this looks like, it's fine. So here we have their demo of a fire. Now let's roll back to, you know, what we can really do with it. The PIMORONI's Galactic Unicorn is basically an RGB LED display board. It's got 53 by 11 matrix of LEDs on the front there, on a panel that is quite big. It's 330mm by 78mm, so it's a good sized display board. Also on the front, before we turn on to the back, we should talk about the photo transistor that's on the side there for light sensing. So we can use that to understand the brightness of our environment and choose how bright we want the display to be. You could actually use it for other things as well if you wanted to, because you know, it's completely programmable, completely usable as a sensor for the device. On the back, of course, is the Pico W, which is what is driving the whole thing. So you've got connectivity to talk to web services, to IoT services, and to use that data to enrich the display in some way. There are 9 tactical user buttons that are completely up to you what you want to use for them. 4 of them have been set up to be brightness, in 2 sets. One set for brightness up and down, one set for volume up and down. But actually they're user-defined buttons. You could still reuse them as anything you wanted. All the buttons are just port-to-ground normal configuration of buttons, so they could be used either through the library that we'll see in a bit, or you could quite easily set up your own intro routines to read them. There is a reset button, which is nice because the main way of getting code onto the device is going to be using the boot select process. So holding down reset and then pressing and holding the boot select button on the Pico W. The board has sound on it. It's a little speaker and a little amplifier, the Max 98357. So we can certainly send 16-bit PCM or synthesize data to it and get it to reproduce sound. I'll show that in a demo. I don't often use sound in my projects, I must admit, but it's quite nice as a little bit of a notification mechanism to have there as an option. True external connectivity, we've got two QWST or quick STEM QT connectors on the board. So that gives us lots of opportunities to either plug in standard modules that conform to those, or build our own modules that are I2C and connect into those. So that lots of potential. Obviously running quite a lot of LEDs on here. There really actually aren't that many other free pins on the Pico, so I'm not surprised that really these two connectors are your only options. For power, you can either push power through the Pico W using the USB port, or there is a JST PH connector on here for connecting up a battery. It's a standard battery connection, you know, for up to 5.5 volt input. It's not going to manage a LiPo battery properly or any of the more sort of capable battery functions. It's simply a direct power in really as a battery feed into the board. What's the board missing? Well, for me, the big thing that the board is missing is SWD, single wire debug capability to plug straight in and program. There is not that available on the board. Yes, of course, that's available on the Pico W, but with the Pico W soldered directly to the board, you'd have to solder off the top of the Pico W to be able to pull the SWD port off. Now, you could potentially do that. I'm not sure I can though, because I'm not sure my hand is steady enough. There are two very tiny little resistors right next to that port, and it is much too easy just to clip them. I'd also say that LiPo management would have been nice, but I think I'm then being a little bit on the picky side. So let's see what the board can do now from the C++ library. Let's take a look at a Hello World example. All of the code for the examples today's video is on GitHub in the repo at this address. I'll put it in the description. So over in Visual Code, I've got our project or repo, and there's 4 projects in that. We're going to start with Hello World, but we'll talk about primitives, light sensors, and the synthesizer on the board as well. All of the projects are going to use the same library, which is the PIMORONI Pico libraries. That's quite an extensive library, also with examples in it that you can get off of GitHub. We actually don't need to use all of these functions, because this is for nearly every Pico board that our friends at Pimoroni sell. So I've written a little tiny make extension or make file to just pick up the files I need. So I need to enable I2C and bus for the Pico. I also need the Pico graphics library, and I need the Pico Unicorn library. So I've done a little bit of work on just defining that and having a little makefile to help get you started and to get me started. Everything we're going to talk about in all of the examples is really based on two parts of that library and 2 header files. There is the graphics Unicorn, which is actually the class to manage the Unicorn. So this is what we're going to do to initialize it, to be able to push some graphics on it, to adjust its brightness, to play even little synthesized audio through it. And then the graphics library, which is their standard graphics package, which allows us to draw pixels, rectangles, circles, text, etc. and all of that stuff. So that's really the sort of graphical canvas that they're going to manage. So let's have a little look at main and what it does. And it's a very simple little utility. We're including the include files for the libraries, and then I've got two objects that I'm going to work on. Graphics, which is basically our canvas, and we tell it that it's the 53 by 11 matrix that we want to work on, and the unicorn itself, which is the device. Then for this example, I'm basically going to do the hello world. So I'm going to put one screen up that says hello, wait 5 seconds, and then hello, and then push up the world bit. So I set up 3 strings to help me do that. So the first thing we have to do is to initialize the unicorn device, and then everything else is going to run in a loop, and there's just a timer in that loop that's just waiting for 5 seconds before it keeps on doing one of 2 tasks, which is either to write hello up or to write world up. Before doing those, each time through, it's going to clear the screen, and you clear the screen by setting the pen color and then clearing. You can clear it to any color. I'm clearing it to black there. The set pen is RGB values. So when we write text, we're going to set the pen to a different color. So here a little bit more blue, and then I'm going to set that to write hello. The parameters here are not well documented in the library, which is my one gripe around this library. There is not one comment in the header files to tell you what these functions are meant to be. With a little bit of working out, I managed to work out that actually, well, you know, that the point is where we're going to write it. The string hello is where we're going to write it. -1 is around whether we want that string to wrap or not. The 20 is the scale that we want to do for the font, and 0 appears to at the end is apparently the angle, though I couldn't get the angle to actually do anything. Then on the so that puts up the text in double size for our hello. The other side of that is we're going to put up the Dr. Johnny A8 world, and I'm just going to adjust that and put that 2 lines, one on the other. You see the scale here is now 1. Once we've written to the graphics, because we're writing to a canvas there, we still then need to apply that canvas to our device, and we do that with the Galactic Unicorn update function. So that's really just how we are going to draw the hello world. The only other thing in here is we're also allowing to modify brightness. So there is the capability to use the adjust brightness function on the Galactic Unicorn to just up the brightness or down the brightness by a delta value. What I'm going to just do is quickly scan to check to see whether the brightness up button has been pressed or the brightness down button has been pressed. If they are pressed, then I'm going to adjust the brightness. Doing that by polling is one approach and one valid strategy. I probably would do this by interrupts, to be honest. In this example, doing it by polling creates slight problems because I've got to create this slightly more complicated loop here where I'm just trying to getting the current time since boot and seeing if 5 seconds has gone since I last did anything, which is a little bit more complicated than perhaps I need. I could just go to sleep if I was using interrupts. There is one sleep. It's at the end of the utility, the function or the loop. The reason it's there is 100% brightness to 0% brightness in the touch of a button. So I found if I put it as a 5-second, millisecond sleep in there, it was usable to adjust the brightness. The place to start with any demo is of course Hello World. So this is just demonstrating the standard font text drawing from C to actually put a message up there. And as you see, we can actually scale it. We can have it as double size for the hello, and then a standard size for Dr. Johnny A and world. So there we go. And of course you can go through all of the colours of the rainbow for your text. The unit also has some buttons in there which can or are standardly used as brightness controls. To be honest, they're just standard buttons. You could use them for anything on the Pico, but if we pick them up for brightness, I'm not sure how well this is going to work on a demo, but let me see if I can turn the brightness down a bit and see if that's noticeable on the camera. Oh, I think that probably is, and disappears. I'll turn it back up to full brightness. There we go. So we can play around with brightness on them. which is quite nice, and the buttons work quite well. Let's have a look at some graphics primitives, circles, triangles, squares, etc. The Pico graphics library also allows us to draw quite a lot of primitives. So, you know, we can draw individual little pixels there, and we can draw rectangles, circles, characters and text. Well, we've already seen text. We can draw polygons, triangles, lines and thick lines. So let's just do a little example drawing some of these graphics primitives. So in this example, it's all set up largely the same. I've even got the strings still defined here, even though I'm not going to use them. Oops, sorry about that. But what I'm actually going to do is, again, initialize the unicorn. Then again, at a 5-second interval, I'm going to go around and I'm going to step through a few different examples this time. So actually I've got a counter controlling my loop. So every 5 seconds I'm going to clear and redraw things, and I'm going to cycle through 4 different colours. So what I want to do is actually I'm going to draw 4 shapes, and I'm going to use my loop and counting from 0 to 4 to select which of the shapes I'm going to do. Now each time I draw them, I want the shapes to actually be different colours and to cycle the colours. So I'm going to set an offset of cycle to select the colours. So I'm just using a bit of modulative arithmetic here just to keep moving that colour cycle through. And I've got 4 different pen colours that I'm choosing from and setting. Then on the main thing, I'm going to go through and I'm going to draw a circle. So first one is a circle, and circle needs to set its position of its center point, and then we can give it a width. Triangle requires us that we give it 3 points, so we'll work out what those 3 points are and set them. Rectangle, to draw a rectangle we have to define a rectangle, which is kind of weird. And to define a rectangle, we basically give it 2 opposite corners, and that's it. And then I decided I'd also do a thick line, so I'm going to do a line. So I gave it the line 2 points, start and end point of the line, and then a thickness for that line. And like last time, we got a little bit of control, so we're updating last to be now to say that, you know, actually we've just done something. We're updating our count because that's what I'm using to keep switching the colours around. Resetting the colour value if or the count value when it gets over equal to 4. And then ignore that, we'll talk about that on the next example. And then we're updating the unicorn with our new graphics canvas. So let's see that running. I think my circle's a little bit cropped there, so I think it probably could do with being just a little bit smaller than that, but you get the idea. It's quite nice, they're quite useful. Would I actually use them a great deal? I'm not sure I would, really. I'd probably more likely get into drawing sprites or glyphs in order to, you know, show little symbols on the screen. But they are quite nice, they're there, you can get them working immediately. The Galactic Unicorn has a little light sensor just there, which can be used to set the brightness of the display automatically. So we can use that to actually perceive the ambient light in the environment and therefore set the brightness appropriately. So let's see an example where I'm going to do that. So this time I'm actually going to again draw some graphics objects. I'm actually just going to draw triangles this time, and I'm going to just do them and change them through colour sequences just like I did in the previous example. So don't worry too much about that. It's all the same stuff that I've just shown you, really. This time though, really what I want to focus on is the fact that we are going to ask the unicorn what is the current light level that it's seeing, and that's a 16-bit integer value. And then I'm going to do a little bit interpreting of that, of in order to get a brightness. Now the brightness I want to set the Unicorn and the LEDs to is a value between 0 and 1 as a floating point number. So after doing a little bit of experiment, I found that an ambience level of 30, I want that the lights sensor is reading, I wanted to be my minimum illumination level, and I wanted that to be 0.3. And anything above 300 I wanted to be maximum brightness, which would be 1.0. This light sensor isn't terribly linear, well certainly in certain tests I wouldn't there. So actually beyond about 300 everything's pretty bright, so that was bright enough. So I do a little bit of maths here just to actually work out, convert from the value that's coming back from that light sensor to actually a brightness figure between 0 and 10, and then I can set that brightness. That brightness does not take effect until you update the Unicorn next time. That slightly fooled me initially, because I'm thinking, I don't understand this doesn't work, the brightness changes randomly. No, it doesn't. It's just that you have to call update to get the brightness to take effect. Now fortunately on my photo studio I can actually turn the brightness and up and down to an extent. So let's see if we can actually notice the screens going down. So lights are off now, so that should be nicely and as dim as I've set it to go, which I think I've put it as 0.3, and as I turn the lights on they should increase in brightness so that it remains largely visible at all times. I'm going to add some sound now to our demos. The process I've gone through to record and get sound onto the board is to record the sound in Audacity, to convert it to be mono, to export it as a WAV file in PCM 16-bit signed format, and then use the bin2C utility to convert it into a C header file. I needed to change its type from constant char to uint8 type, but apart from that, that's the process I've gone through to get this to work. There's also a tiny speaker and amplifier on the Galactic Unicorn board, so we can actually make it play some quite reasonable sounds. Whether we want to make it make sounds is another matter. I must admit I don't often do sound in my projects, but yes we can. So we can make it play a little bit of sound. So in this example, every time the graphics updates, that's every 5 seconds, I'm going to play a little sample, and you just issue the command play sample and then the audio and the length of that audio, and that's just a massive array of bytes. And here is that massive array of bytes. Now I'm not sure how much I would use this, especially as this small recording of me going "this is the way" took 50,000 bytes to store in memory. That's quite expensive, certainly without an SD card or some other backing store against the Pico that's actually going to start storing your audio samples. Then this is, I don't know, this seems like a lot of RAM that I'm using to hold this sort of audio. So would I do this a great deal? I don't know, but it's an interesting little feature. Seems to work quite well.
This is the way. This is the way. This is the way.
So let's sum up. What do I think of this display? Well, I think it's actually a great display board. It's really useful. I love the stand. It's simple, easy, and really functional. Its connectivity is pretty good as well. Having two of the quick connection points is very useful. Certainly plug in any I2C devices into it, and I have plans to do that in the future. It's very usable C++ library as well, which is great. On the negative side, the lack of SWD connections out of the board I do find a little bit annoying. I would rather have SWD available to me. Yes, if I was really careful at soldering, I could probably put a connection on top of the Pico W, but actually there are some resistors really close onto the top of that board to the SWD port, and I'm not sure my hand is actually steady enough to do that. So I really would have liked to have SWD broken out for me. The lack of comments in the C library I find a little bit surprising. That would have been an easy thing to do. We've got the comments for the Python library. Why is there no documentation for the C library? It just creates, issues when, I'm trying to look at functions like text and what does S mean and what does A mean? How am I meant to know that they're meant to scale and angle? And finally, I think, as perhaps a nice to have, it would have been lovely to have LiPo management on board, so that I could just run it off a LiPo and recharge it and use the board to do the recharging. That would have been really cool. So the PIMORONI Unicorn, it's a great little board. In fact, I like all of the boards in the Unicorn range. The PIMORONI Galactic Unicorn is really great. It's got a nicely written library, which makes it a pleasure to use and be able to produce little displays and signs, smart clocks, a whole load of use cases. So I hope you enjoyed it. Hope you find it useful. If there are other boards or products within the RP 2040 world you'd like me to look at, please let me know and I'll see what I can do. Thank you very much for watching today. I really do appreciate it. Please like the video and subscribe. That really helps me. And also take a look at my Patreon site to support my work. I would really appreciate that. Thank you very much and I'll see you soon. Goodbye for now.